Yeah, I'll start in a second. We'll be doing EEG synthetic generation. So I had this tool sitting there for quite some time, but we need to improve it, write a description, and combine it with another tool that has a synthetic noise generation generator. So in this case, yeah, this one's pretty simple. Again, we need to write a description for it. So we'll talk about it in a sec, and combine it with a synthetic EEG generator. We had something like this working in LabVIEW quite some time ago, but we don't have license anymore. So redoing everything in Python and JavaScript. Mainly trying to rely on JavaScript just to reduce the load on my server. So we essentially will be combining this two tools. Okay, let's jump into it. So on the EEG generation side, yeah, we have a lot of the stuff is done in Python. We'll be So we're not going to be redoing this. We're going to be probably generating a new tool out of all of this with better functionality. Currently we're just writing the technical details. So this is running on a server. Yeah, so we have the features. Let's read this quickly just so yeah, because we'll be publishing it, so we need to review it.
The synthetic EEG signal generator is a web-based tool for generating artificial EEG signals for testing and evaluating various algorithms, devices, or theories related to electroencephalograms, EEG. This Flask-based application allows users to adjust parameters such as amplitude, bandwidth, and window size to create synthetic EEG signals and visualize their spectra.
Yeah, that's correct. Yeah, the spectrum is this bar chart, so it's not great. How about we add the limitations section? So we have future directions. Yes. We'll add the limitations. So Control I. We're using Copilot for now. We're not using GPT-4 at the moment. I want to turn it into H2 header. I don't know why it's normally thinking, well, quite a long time for something like that. So in this case, it's only taking stuff I would imagine from the HTML. It's not looking at the backend. We do have a description for the backend. Yeah, it's a Flask application. Can we generate a description in one paragraph that we can use on the HTML page? Use define parameters. Yeah, we can adjust the window size. I think we pretty much mentioning that already. Window size, yeah, visualize. And frequency include talent. Yes, the application then generates time series, synthetic EEG, calculates the power spectrum. Format these documents just so it fits into a screen. No, it still doesn't. Hey, nothing fits. Frequency using the Welch. Do we mention Welch method? I wonder if it's actually, so if we're just sitting in the HTML file, a feature synthetic G signal spectrum, applications. That's like a general overview. In technical details we can have so this is around the Python a code. And this will be H3. Is it using SciPy? Yes, it's using SciPy library processing, including generating sensor the waves, applying a window function, calculating power spectra. That's correct. Hey, don't worry about deployment. I just place P, we'll turn it into a paragraph. No, it won't. Control I. Okay, that seemed to work. Simf. I don't like how it's like drip feeding information. Should just you know spill it all. But it is accurate enough. Just quickly read the. Yeah, so the features are okay.
The synthetic EEG signal is generated by combining sinusoidal waves for different frequency bands, delta, theta, alpha, beta, gamma, with adjustable amplitude and bandwidth parameters. The signal is then windowed to create segments of data for visualization and analysis.
Yeah, that's more or less correct.
The EEG spectrum is calculated using the fast Fourier transform, FFT, algorithm to convert the time domain signal into the frequency domain. The resulting power spectrum shows the distribution of signal power across different frequency bands, which can be used to analyze the characteristics of the EEG signal.
Yeah, that's generic stuff. Maybe we don't need those labels for it. Just an overview, really.
Research and development of EEG-based technologies and applications. Testing and validation of signal processing algorithms for EEG data. Education and training in EEG signal analysis and interpretation. Simulation and modeling of brain activity for scientific and medical purposes.
Yeah, that application should be fine. It's again generic stuff.
The synthetic EEG signal generator is built using the following technologies. Flask Web Application Framework for Python. Plotly Library for interactive data visualization. JavaScript and Ajax for real-time updates and interactivity. HTML and CSS for user interface design and layout.
That's fine. The other thing I realized that every time you load it, yeah, it's generating this random EEG. Then you can adjust it, but on loading the page, there's some randomness to it, which is a bit odd. Yeah, just that number is really small there. Hey, this is your amplitude control. Yeah, amplitude should be. Oops. Yeah, so this is random. Yeah, there's some noise embedded in it. That's why the randomness. I get the slightly different result every time I run the application. Why is that? Yeah, so the bandwidth can be improved a lot by getting rid of the bar chart and actually doing a proper bandwidth, because then you can see when changing one of those, the alpha there should be going wider. Currently, yeah, really weird. Something's wrong. Yeah, when changing those, you should see essentially this bar, if it's a proper chart, becoming much wider. So that's what we're gonna be doing in the next version of this. Yeah, we have the frequency set to random. Frequency. Yes, we have the frequency range. The frequency should not be random, it's the amplitude if you want to add noise to it. And that's a bit odd. So generating a random frequency within the specified frequency range for each EEG band. This frequency is randomly chosen each time the function is run. The resulting in static EEG data will vary slightly with each execution. This is intended to simulate natural variability seen in real EEG. Still felt it would I thought we will be varying the amplitude instead or in addition to. Let's see. Actually, not a bad description. It should go into. Should we have another technical detail? No, Python backend. Yeah, there should be another. Python is generating. Yeah, there's some randomness. To the thing. Turn it into a paragraph. I don't know why it's formatting it in a weird way.
Python is generating a random frequency within a specified frequency range for each EEG band, delta, theta, alpha, beta, gamma. Because this frequency is randomly chosen each time the function is run, the resulting synthetic EEG data will vary slightly with each execution. This is intended to simulate the natural variability seen in real EEG data.
That's, yeah, fair enough.
The front-end interface is designed using HTML, CSS, and JavaScript to provide interactive controls and visualizations for the synthetic EEG signal and its power spectrum. The Plotly library is used to create dynamic charts that update in real time as the user adjusts the parameters.
Just making sure, yeah, we're using Plotly. That's fine.
The synthetic EEG signal is a simplified model and may not fully represent real EEG data. The signal generation process does not account for noise or artifacts present in actual EEG recordings. The application is designed for educational and research purposes and may not be suitable for clinical use.
Well, that's for sure. Let's do with a workspace function update based on backend code. It's collecting data forever. The project is small. It's well, it's tiny. Okay, let's see if we try to regenerate it. Come on, not right. Okay.
The synthetic EEG signal generator is a simplified model of real EEG data and may not capture all the complexities and nuances of actual brain activity.
Yeah, that's better because it does. Before it said it didn't have noise. It does have noise.
The generated signals are deterministic and do not include noise or artifacts that are commonly present in real EEG recordings.
Okay, with the workspace handle, so it has access to the whole project. Didn't we just say that we do have a noise generation in Python? Yes, we generate random frequency components. Okay, so can we update this then?
The generated signals are synthetic, simulating EEG-like data with user-defined parameters. While they aim to mimic real EEG recordings, please note that they may not include all types of noise or artifacts commonly present in actual EEG data.
Okay, this is better because it says they do not include all types of noise, because they do include some noise. So
the frequency bands and parameters used in the generator are based on general guidelines and may not accurately reflect individual differences or specific conditions.
Yeah, that just sounds like a general disclaimer. That's fine.
The power spectrum calculation is an estimation based on the FFT algorithm and may be affected by windowing and other factors.
Yeah, that's the one we need to improve later. The EEG spectrum currently it's using bar charts. Is that a limitation, and how can we improve this in the future version of this web application? Using the bar chart is not necessarily a limitation, but rather a design choice. Yeah, it's not a bug, it's a feature, isn't it? Charts are simple and effective for comparing quantities across different categories, in this case different frequency bands. However, there are potential improvements that could be made in future version. Use line charts for time series data if the EEG spectrum data is time series. Changes over time. A line chart might be more appropriate. It would allow users to see how the power in each frequency band changes over time. That's not what I meant. It's not exactly what I meant. I meant instead of bar chart, should we use a linear distribution? So a distribution graph. It's a power distribution. Yeah, it's already writing the code. Okay, this is what Copilot is better at. Maybe we'll start using GPT-4 quickly to give us the general context as well. Consider switching from bar chart. That's right. Format selection. Turn it into HTML text.
Consider switching from a bar chart to a distribution plot for visualizing the EEG spectrum. This can indeed be a beneficial change. A distribution plot, or a histogram, can provide a more detailed view of the data. Instead of simply showing the average power in each frequency band, a distribution plot would show how the power is distributed within each band. This could reveal additional insights, such as whether the power is evenly distributed or skewed towards certain frequencies.
That's right. That's pretty good description. We will be leaving this one as is. It's available on the website somewhere down the bottom because we haven't touched it in a while. Yeah, synthetic signal generator. And we'll just be adding this description and eventually a new version of it. We need the same type of description for the synthetic noise generator. Synthetic noise generator. Okay, let's copy this just as a template. No, we shouldn't. We should not do that. Do we have a JavaScript? Why don't we have a dedicated that's a bit odd, but okay. Yeah, I have to be careful with those as styling files, CSS files, because we do have a CSS for the whole project. So we definitely do not. Yeah, we don't need footer main. Don't need that select navigation. No. Right, I just realized the previous tool was generating a lot of stuff. Do we actually need it? Hey, probably not. Yeah, because we're not troubleshooting anymore. Hey, let's find any print data. No, we don't want to print that. Okay, this is bad. Just has a request, API request. That's better. Okay, this has this Python code. We don't mind it's all open source stuff. It's just the only thing is I can only control what's on biomedical.com. On my website, I cannot control any other website. But yes, the code. Now, if you can somehow access it from the website, you should be able to access JavaScript. Let's see. Yeah, you have the JavaScript script. Does it have a script? Yes. Don't think it does. Submit form. What's the window listener? What? Invest F noise doesn't have a JavaScript file. So I don't know what's up with that. Let's keep going quickly. Yeah, I'm not entirely sure where I have to clean up my whole project. Because I think I know what the problem might be. And no, I was wrong. I don't actually know where that script.js is coming from, which is really odd. It says it has a in static folder we only have we only have the CSS, so it must be coming from the DNS server. I have to clear it, so it fetches data from my server. But anyway, the point is we need a description. We already have. Yeah, we have a description is incomplete. No, that's not OJ description. There's, by the way, no pink noise. We need to add the pink noise. No, this is rubbish. Come on. The web application that generates synthetic noise signals. Including the white noise, periodic noise, and inverse F noise. Allows users to select the type of signal they want to generate via the signal in both time domain and frequency domain. Provide options to download. No, it doesn't. Future. Yeah, I want to provide an option to download generated noise signal CSV file. Yeah, we need contact forms everywhere, but we won't worry about that for now. Adding more noise signal types such as pink noise and brown noise, allowing users to customize parameters noise signals such as the amplitude, okay, and frequency, okay. Provide the option to download. It's more like technical details. Why is it refusing to generate? Why? I commented out. Come on. It's weird. Yeah, I think how to use this pretty is straightforward. We could use an overview. A white noise, periodic noise, inverse F. Right, this it's not running. The only thing is with this styling is that we wanted to, oops. Hey, we wanted to fit this screen. It's taking some time to load as well. Yeah, because we have styling for the whole project, we only need the styling for specific features of the application. We can do them within the HTML itself. Why is that a placeholder? It should be a placeholder, that's fine. So is this standard? Can we improve this? Just adding some hair and handling. I don't need hair handling. Yeah, I have a time chart, a frequency chart. It should be more straightforward, is it? It's still working. Yeah, I want the two charts to fit the screen. Yeah, that's the original. Yeah, it's loading for quite some time because of the backend. Can we make sure the two charts fit the screen? No, we don't want 100% width. We want the two charts to always be visible on any screen size. We want the two charts to take about 70-80% of the screen. We actually want the width to be that doesn't do anything. How can I make the header, the drop down, and the two charts always fit the screen? No, that won't work. Anyway, we'll have to continue this later. Finish that description. I'll see you in a bit. Go check out biomedicals.com. There's lots of interesting tools for you to play with, blogs to read. Don't forget to provide your feedback.